All right. So my name is Paul, and I'm here together with Sander, and we're going to talk about Java 9 modularity. It's just not about Java 9 in general, but specifically about the module system. And there's a good reason we're talking about this, because Java 9 is coming in about a year, and we started diving into this topic. And what we ended up doing is actually write a book about it for O'Reilly, which is still well in progress, of course, because that will be released just before the Java 9 release. So that's why we started doing these talks, and definitely also check out the book for that, but more about that later. So what are we going to talk about? First of all, just look a little bit at modularity in general. Why should we care about modularity in the first place? And why is this important all of a sudden after so many years of Java without a module system? After that, we will look into what Java 9 will offer us when it comes to modules. We will look at how to declare modules. We will actually have quite a lot of code to show. And one of the new aspects that become really important are services. So we will look at that as well. We'll look at how to actually build images using Java 9 based on modules. In the end, we will also look at how to migrate your existing code to Java 9 modules. So let's dive right into it. First of all, why should we care about modularity? Well, something that I often say to people as well, modularity is the ultimate agile tool. And the reason for that is that if you don't have a modular code base, well, we pretty much all know what happens then. You change something at some place in the system, and something breaks on the other side of the system, and you just don't understand why. Somehow there was some relationship between that code that, well, probably shouldn't be there, and at least you were not aware of it. If you have a properly modularized code base, it becomes much easier to reason about what the impact of changes will be. So if you make a change to a certain place in the code base, you know what's going to happen. And of course, it's just an architectural principle. This is not just about the technology. It's not just about Java 9. This is something that is really old. This whole concept is really old. But it's one of the most important concepts in software to actually have a maintainable code base. So that's why this is really important. And if you dive a little bit deeper, then, well, one of the core things about modularity is to have good fences. So what we want to express when we talk about modules is that we have some implementation code, and that implementation code, well, that can be tightly coupled, because if there's no coupling at all in code, well, you pretty much just can't do anything. So within implementation code, there may be coupling, but then you want to draw a big box around it and call that box your module. And then you have other modules in your system, and the only thing that those modules should see from your module that you're working on is a service contract. They shouldn't know and they shouldn't care about your implementation details, but all they should know about is an API. And this API, that's what you share with the rest of the world. That's what you share with other modules. And that should be the only way of interacting with that module. I think this all makes sense. And I think most people who actually start designing software on a whiteboard, they actually do draw these boxes which represent modules on the whiteboard. But then when we get to actually coding, especially in Java, we kind of lose that a little bit, because Java doesn't have strong constructs to define these modules. What we do have in Java is, of course, the public and private and protected keywords, but that's not really at the level that we're looking for. That's at a class level, and we need something at a higher abstraction, something around those classes and interfaces to actually define a module. And that's one of the things that will be coming in Java 9. So of course, keep in mind, Java 9 is not finished yet. It will be released summer next year. That's the current schedule. And that means that, well, it's still work in progress, and we still expect some changes. Because we're getting pretty close to a point where, well, they should stop making changes all the time, and things will get more stable. Most of what you will see today will probably end up in the final release. Just keep in mind, it might be a little bit different. Looking at Java 9, there's several goals why they started working on a module system. The first goal was actually, well, looking at the JDK itself. The JDK became really large. Of course, Java is pretty old already. And over the years, a lot of technology was added to the JDK that might or might not still be very relevant. The JDK used to be just one big monolith, and that meant that if you want to run a small Java application, maybe just doing something like an hello world, you had to drag in the whole thing. You had to download a complete JDK to actually build it. And even if you start up this small application, well, pretty much the whole JDK had to be started. So that means a lot of overhead. It's not very efficient. And with new Java releases, this problem only gets bigger because, well, backwards compatibility is really important for Java. So that means they can't really remove anything that used to be there. But of course, new functionality will always be added. So what I did is actually split up the JDK and make that a lot more efficient. More about it in a minute. The other thing, and this is probably more relevant to us as developers, is that we will also get a module system that we can work with. So we can use this module system in our own code to modularize our own code. And then we really get the benefits of modularity in general, but it also means that we get a more reliable way of composing applications. And we will actually see in the demos how that helps in practice. So you can kind of say that it's partly about modularizing JDK itself. We will have benefits on runtime performance and less overhead there, and we will get the same module system that they used to modularize our own code and actually make our own code a lot better. Because they modularize the JDK, that also means we can look at a module graph of the JDK. And that's this picture with way too many arrows right here. But remember, the JDK is really large. There's a lot of code in the JDK. And that also means that if it's properly modularized, there's lots of modules. All the way at the bottom, we have the base module, and that's always implicitly there. And the base module contains classes like Java lang object, and Java lang string, etc. The collection classes, all those basic things that you always need when programming in Java. The interesting thing is that if you would write an hello world using the module system, base is probably the only thing that you will depend on. And when you start this kind of application, base will be the only thing that will be started. So that means a lot less overhead. Then we see all kinds of specific technologies, even something like Corba, which is modularized towards its own module. And it means if you don't use Corba, like probably or hopefully most people do or don't, if you don't use Corba, you actually don't need that module at all. And that's really nice because, well, that's a really good way to actually deal with this kind of outdated technology. We also see that compact modules are there, and these represent the compact profiles that we got in Java 8, and they aggregate a subset of the complete module graph. As I said, the fact that the JDK itself is modularized is really nice because it means a lot less overhead. What's probably even more important for us is that the class path is going to disappear. Well, don't worry just yet. Actually, in Java 9, the class path will still be available. So if you don't want to use the module system yet, you can just run your applications using the class path like you would do today. At the same time, there is something better coming. That's the module path. And that means that slowly we will move away from the class path and get to a much more reliable setup. Because like we all know, the class path is just flat. And it's very easy to make mistakes, either just missing classes because you forgot some kind of dependency and you will find out at runtime. Maybe you have duplicate classes in different versions, which causes problems. All in all, it's just not reliable. Instead, you will get a much more reliable model where we can define a module. And even more important than that, a module also defines dependencies on other modules. So I have my module here, and it requires explicitly another module. And using this requires is the only way that my module can read types from the other module. That also means that this metadata will be available both at build time and at runtime, which makes this more reliable model possible. And this whole thing will replace the class path in the end. Something else that we get with the module system is strong encapsulation. And this is both for the JDK, but also for our own code. Let's take an example of the JDK. In Java base, there are some types coming from some packages that are still available for us to compile against. These are things like Java lang, Java time, etc. These are the types that you're supposed to use in your own code. There's also a lot of types in the JDK that you're not supposed to use. Things coming from the Sun Star packages, for example. Unfortunately, a lot of people have been using those types, but with Java 9, this will not be possible anymore. They're fully encapsulated, which means they're just not accessible anymore. And that means both at build time, but even at runtime using reflection. This is all checked in all phases of the application. Encapsulated just means fully encapsulated, and that means you can't access it. All right, so enough talking of this stuff. Let's first look at some actual modules, and Sander will give us some demos for that.
Okay, so that all sounds great in theory, but the question is, of course, what does it mean for me when I'm going to develop applications using the module system? So what we're going to show you is a demo application called Easy Text, because frankly, I'm quite sick of Hello World applications, so we're going to look at something a bit more interesting. And this application can read a file, text file, and it can analyze the complexity of the text. Well, so we're writing a book. I wonder why we need that. Anyway, this code is chopped into two modules, and the first module is the so-called Easy Text CLI module, which handles the file reading and the printing to the command line again. And it delegates the analysis of the text to code that resides in the easytext.analysis module. So what we see here is an explicit relation between the CLI module and the analysis module, which we'll work on in the demo as well. I'm going to switch to my editor here. And one of the first things you might notice, no, it's not a Java IDE. And that's not because I hate IDEs. Okay, maybe Eclipse, but anyway. This is because we're going to use the bare bones Java compiler and Java command from the command line. Doing this ensures that you really see what's going on under the hood. Also, the IDEs currently don't really support Java 9 yet, at least not all the cutting-edge features that are in the Jigsaw builds. So this Jigsaw prototype that I'm going to show you will give lots of red squiggly square lines in your IDE. Another reason to just go back to the basics. So what I'm showing you here is the layout of a source tree that contains modules. So normally, in the source, you would have your package hierarchy with your packages and your classes. But in this case, we have two additional directories, Easy Text Analysis, Easy Text CLI. And these, of course, represent our modules. Now, what makes this a module is the fact that these two have a module descriptor in the file called moduleInfo.java. And let me open them. They're currently very, very simple. This is the simplest valid module descriptor that you can create. And we just declare a module, and we name it EasyText.CLI. And the analysis module here has a similar one, only with a different name. And this is actually all there is to creating a module in Java 9. Just create a module descriptor for your module and compile it. So let's try that. We're going to use a new flag in the Java compiler, which is called module source path. We're going to point this to the source directory, which contains, in this case, two modules. So we're going to compile the two modules together. We have to define an output directory. Let's do it in out. And you may forget this if you're using Maven or Gradle or any other build tool, but in practice, when you use Java directly, you have to provide all the source files that need to be compiled. So in this case, I'm going to use a little trick to quickly find all the Java files and feed it to the compiler. If we're going to do this, it should be good, right? Because all the code is there. Well, no. Let's see what's going on here. So we have an error saying that my main class, which we have here, which should just be doing simple things like reading the arguments, reading a file, chopping it up into sentences, and then calling an analyze method on new flash Kincaid. Flash Kincaid is a implementation of a text analysis which lives in a different module. What's going on here is that we're using code from EasyText CLI that lives in the EasyText analysis module. And even though we compile all these files together, the compiler still warns us and says, well, you can do that. You don't see flash Kincaid. It's not visible yet. And that's exactly what we can do with the module descriptors here. So what we need to do is we need to be explicit about what we require for this module. This module requires the EasyText analysis module. So there we go. We've explicitly said that we require EasyText analysis, and we're using code from it, so it should be all good right now. Let's try it again. And unfortunately, we still get this error that says, okay, flash Kincaid is not visible. What's happening here? So on the one hand, we have this explicit dependency that says we're using the module requires the module EasyText analysis. On the other hand, if we look at the module info of EasyText analysis, it's quite empty still. And this behavior that we're seeing here has everything to do with the defaults of a module. By default, a module exposes nothing to the outside world. If you want to expose something as an API of the module, you need to be explicit about it, and you need to tell the module system. So in this case, we need to say this exports, and where requires in our previous module scripter took a module name as argument, an exports clause takes a package name as argument. So in this case, we can choose which packages to expose. Well, we only have one in this very simple example, so we're going to expose that one, the analysis module, where coincidentally the flash Kincaid class lives that we need from main. And we're going to compile again. In this case, we get a successful compilation. So what we saw here is that the compiler already helped us to only use code that we explicitly want to depend upon. So no more accidental uses of classes from dependencies that you really wouldn't want to use, but you accidentally use them because you have them in your class path or in your IDE, etc. You need to be explicit about this. Furthermore, if we look at the output here, we can see that we get the compiled classes, which is logical, but we also get the compiled module descriptors. So module descriptors don't only work at compile time, but they're also used at runtime. So let's first try and run our application with the Java command. And in this case, we're going to set up the module path rather than the class path. And the module path, we point it to our compiled modules, and we're going to run the module easytext.cli. We still need to tell it which class from this module to start because it's not packaged yet, so it doesn't have a main entry point defined. So we're going to say easytext.cli.main. It prints a welcome message, says, okay, give me an argument. In this case, let's give it chapter 3 of our book. And we get a flash Kincaid score of 60.70. So whether that's good or bad, I'll leave it as an exercise to the listener. But we have a working application with 2 modules and explicit dependencies. You might be wondering, okay, so class path, module path, what's in the name? What's the big difference here? Seems all the same to me. So I'll give a short demonstration of what happens if, for example, our module path doesn't contain one of the modules that we need. So let's try and run the application again, like this. And note that here we only reference the CLI module, right? So we don't say anything about the analysis module, but the virtual machine can read the descriptor that's bundled with the CLI module and know that it needs the analysis module. And if it's not there, it will complain about that at startup time already. So it says, okay, I cannot resolve this module graph for you because you want to run EasyText CLI, but I need EasyText analysis, and it's not there. This is so much better than the class path where we would just blow up at some arbitrary point at runtime. Once the class is loaded, that's missing or that's duplicate or whatever problems you can encounter from the class path. So this is a fine example of the reliable configuration that Paul talked about. So to recap, we have 2 modules, explicit dependencies. We compile them. The module definitions are preserved at compile time into runtime, and it's actually used to help you start your application reliably. So for our next demo, I'm first going back to some theory. Because on the one hand, we have a nice decomposition between two modules, analysis and the CLI module. On the other hand, these two modules are quite tightly coupled because we had a new Flash Kincaid instantiation, and that's fairly tight coupling to an implementation class of the other module. What we really would like to have is have some sort of interface that we can talk to from the CLI module and an implementation class in the implementation module without having to export that, without having to expose this implementation. But the question is, how do I get an instance of a type that implements the interface if I cannot access the class that implements it? Well, like with all problems in computer science, it can be solved with an additional layer of indirection. And in this case, this additional layer of indirection is a service registry. The idea is that we can have consumer modules, and consumer modules need to use a service of a certain interface type. So they want to look up a service in the registry. And the instances that get returned from this registry come from provider modules. And a provider module has an implementation class that implements the interface and offers that to the service registry. But in this way, the consumer module is completely decoupled from the provider, and the other way around, same story. So they don't need to know about each other. And this is a perfect way of doing inversion of control. And of course, lots of applications use this in a similar way using dependency injection. It's all the basic same idea. It's don't call us, we'll call you. And in this case, what we want is decoupling through interfaces. So how does it work in the new upcoming Java 9 module system? Well, in that case, what we would like to have is a module that is called MyAPI in this example, and it exports the COM API package, presumably containing an interface that we're interested in. And a module consumer, MyConsumer, requires this API module because it needs to know about the interface type in order to call methods on it. But it also has an additional clause which says, uses COM API MyService. So I, as a MyConsumer module, you will want to use instances of the COM API MyService interface. Then the question, of course, is, okay, if I have a consumer, then where's my provider coming from? Of course, from another module, or maybe multiple other modules. That's all possible. And this module, MyProvider, also needs to require the MyAPI because it needs to implement the interface, so it needs to read the interface type. But additionally, it also provides something of type COM API MyService, which was our interface, our public interface, with MyProvider MyService impl. And this MyService impl class is a class that is not exported from the MyProvider, as you can see. So it's encapsulated, it's not accessible by MyConsumer or any other module. And with this setup, what we have is a wiring between services that's mediated through something called the service loader. And the service loader API has been part of Java for a long time already, but only now it's being retrofitted onto the module system, and it will, in our opinion, gain a more important role again. And what you now can do inside of the consumer module is call serviceloader.load, pass it the MyService interface as a class object, and get back an iterable of all instances that have been registered as providers for this interface type. And then you can iterate over them, use them, select one, or if there's only one, just use it. However you want to do that in your application, that's up to you. But this way, through the service loader API and the uses and provides clauses, we can gain more decoupling between modules. So of course, we're going to look at an example of that. And I want to add something to that. Because modularity is not only about hiding things, it's also about creating systems that are easily extensible. So I want to show you that in this example, we started with a command line interface, but why not just add a module that creates a GUI and talks to the same analysis logic and reuses that? So we're going to show that, but we're also going to look at the application of services. So in this case, the analysis phase is, of course, a prime example of something that we want to decouple through services. What if we have an analyzer interface and multiple implementations? It would be great if the CLI and the GUI are independent of the actual implementations and can just discover the implementations through the service loader. So if we have a look at that from a high level, we can see the following pattern emerging. We have a new module, EasyText Algorithm API, which contains the analyzer interface that I talked about. And the two front-end modules, EasyText CLI, EasyText GUI, both require this because they need to know about the type in order to call methods on it, but only about they know only about the interface in the API module. They don't know anything about the EasyText algorithm implementation modules that are on the bottom. So there's a Kincaid and a Coleman implementation. Both are different text complexity metrics that we've implemented. And these two implementation modules also depend on the API because they need to implement this analyzer interface. But there's no direct coupling between the front ends and the implementation of the analysis services. There's only an indirect coupling through the service loader that we already saw. And this happens at runtime, and the wiring is done by the module system as well, between services, consumers, and providers. Now, in this case, we also added JavaFX graphics and JavaFX controls modules in this picture because our GUI module uses way more than the types that are available in java.base. In the previous module descriptors, we didn't have any requirements on JDK modules because java.base is always implicitly a requirement for a module. But in the case of our GUI, we also use types from JavaFX, so we need to be explicit about which modules we use from the platform. So let's switch back to the code again. As you can see, we have a source directory containing a fairly large amount of modules in this case. We have our API, we have the two implementation modules, and we have the CLI and the GUI. And just for reference, I'm going to show you part of the code of the GUI module. You can see that I import lots of JavaFX types here. So that's why we also need to require some JavaFX modules from the Java platform. I'm also using the analyzer interface, which comes from the API module. But you can see there's no import here for specific implementation classes. And that's because in our main method, we're going to retrieve the service implementations using the service loader load method and provided our analyzer class. And of course, looking at our module info, we need to declare the fact that we use this Java Modularity EasyText algorithm API analyzer interface. So the module system knows that we want to have instances of this analyzer and it can wire it to us. Looking at the module descriptor a bit more in detail, we can also see that we have two require statements on JavaFX modules. Those come from the JDK itself. So this is a part of what Paul has already shown in the big graph. And we require the API module because we need to know about the analyzer interface. So if we're going to run this, and I'm going to use a little script because I hate typing too much, something interesting is going to happen. What we see here is that we have the application, it starts up, there's some text that we can analyze. But the idea was that we would have analysis algorithms here to choose from. And instead, it's an empty dropdown. So what's going on here? Well, we've declared that we consume services. But if we look at the module info of the implementations, we also need to declare that we provide this. So we're going to say provides Java Modularity EasyText algorithm API analyzer. We provide it with specific implementation class that we're not going to export, but in this case, we're already in the context of the specific implementation module. We can say, okay, Coleman analyzer is the actual class that will provide the implementation of the analysis. And we do the same for our Kincaid implementation module. But of course, with the correct package and class. There we go. And what you see is that this in turn uses another service. So this can all be done transitively, no problem. You can provide and consume services that at the same time as a module. And let's try and run this. As you've seen, we haven't touched any code besides the metadata in the module infos. And still, now we can select the algorithm. It will calculate it for us. We can select the other algorithm. It will calculate this one. And the nice thing is, if we add a new module to our module path, that contains another provider implementation, maybe some we even didn't build, but somebody else built using the same interface, then it would appear automatically in this drop-down as well, because we dynamically retrieve the services at startup that have been wired to us by the module system. So this is one way to achieve decoupling between modules.
We got a question from the Barcelona Jog, if now's a good time.
Yeah,
sure. Awesome. So Barcelona Jog, if you just wanted to unmute yourself and ask away.
Not hearing them then yet.
Is Nacho, are you there?
Are they still muted?
Yeah, still muted, yeah.
Well, that's an easy question then. Shall we save it for the end?
I've got the question here I can ask.
Okay.
So can you guys hear us?
There we go. We can hear you now.
Okay.
Paul, I think that you can expect this question, but if you already have OGI, why do we need this static modularization in Jigsaw?
Okay, so the question is, if you have OGI in your application, why would you need Jigsaw? And the answer is, at the moment, you really don't, because like Paul said, you can just use class path-based applications and use your OGI implementation on the class path and be done with it. The idea is, of course, that OGI has always been something extra, additional on top of Java on the platform. And if you're going to use a library which doesn't have OGI metadata, etc., then you have to do some additional work. The idea is that the module system itself will be something that becomes part of the whole Java platform. And once this rolls out with Java 9, it becomes much more approachable for the everyday developer to actually use modules rather than going all in with OGI. You can gradually roll into modules using the Java 9 module system. And Paul, within a few minutes, will also show you how this actually works if you want to do this in a stepwise fashion. So you don't have to go all in like with OGI, where everything is a bundle, everything has metadata, etc. The Java 9 module system offers a more gradual path there. So I would like to finish off this demo by showing what I think is a very cool application of the module system and all the module info that you create. Because, well, we already saw with the module path that it helps us somewhat when starting to get a reliable configuration. But what's really cool is that you can also create custom runtime images, which means you can create a runtime image of the JDK containing only the modules of your application and the modules of the JDK that your application needs to run. So the tool to do this is called jlink. In this case, I'm going to provide it a module path to the jarred modules of the EasyText application. I'm also pointing it to the modules of my full JDK. The cool thing is you can point this at any JDK. So if I would point this at a JDK for Windows, for example, even though I'm on the Mac, I can create a runtime image that will run on Windows using jlink. I'm going to add the modules that I want to have resolved in this runtime image. And I add CLI, and it will automatically pull in all the modules that CLI needs based on the required statements that are in the module definitions of EasyText CLI. I'm also adding service implementations, so the service provider modules here. At the moment, jlink doesn't resolve all services directly, and there's a fairly interesting discussion behind that, which I'm not going to get into, but in this case, we need to add them explicitly if we want to have them in our runtime image. There's all kinds of tweaking that you can do here to make the image smaller, but let's just do it and create a image. Okay, something's not quite right here. I'm in the wrong module example here. There we go. So when I create this image, I will get an output directory image. It contains bin conf lib, and it's actually a full Java JRE. It contains a Java command. It also contains an EasyText command where I can directly launch our EasyText CLI application without setting anything up. That's already done for us based on the module metadata. And I can also ask Java virtual machine that has been output here. Okay, so what modules are actually in this image? and it's a very small amount. So there's only Java base and the modules that are part of our application. So if you look at the size of this image, it's 21 megs, which is really, really small in comparison to, for example, the full JDK. If we, for example, have a look at the size of Java that I've installed here, it's 407 megs. So that's a pretty big difference. We can also see that if I create a runtime image for the GUI instead of the CLI, we would expect more modules to be part of this runtime image, of course, because we pull in JavaFX, 2 modules, and maybe they pull in even more transitively. So it's also taking a bit longer, which already shows that it will be a bit bigger. And in this case, we have an image of 49 megabytes, which is still much smaller than the full JDK. And if we look at the modules that are now in this image, we can see that all the easy text applications modules are there. There's also Java base, which was previously there, but also the JavaFX modules that we required, and all the modules that they in turn require, and they in turn require, etc., etc. This is all resolved for us by jlink. So this is something that can help you to create very nice small images out of a modular system. So with this, I'm going to give it back to Paul, because it's also interesting, of course, what are you going to do if you're not in a greenfield situation, but you have existing code and you want to move towards the module system. So there you go, Paul.
All right. So the very first thing that you should probably do is try to just run on Java 9 using the class path like you would do today on Java 8. That would be a very good start. And as I talked about in the beginning, the JDK has changed. The JDK itself has been modularized, and that also means that some of the internal types that were available in Java 8 are now encapsulated, and you can't use them anymore. So that will lead to errors once you start running on Java 9, even if you're still in a class path. Of course, you can just try to run your application on Java 9. That would actually be a nice experiment. There's also a very useful tool called JDApps. And JDApps analyzes your code. You can just give it a bunch of jar files or class files, and it will analyze if you're using any internal JDK classes. So that's definitely something you should try out. JDApps is already part of Java 8, but it's advised to actually download Java 9 and get a version available in there, because there's lots of updates that they don't backport back to the Java 8 version. Once you find that there's problems, let's say that you are actually using internal types, the best thing to do is, of course, move away from those types, because there's good reason they are encapsulated, and you shouldn't be using them. There's a few types like unsafe that don't have good alternatives outside of the JDK, and they decided to keep those available in Java 9 as well. So it's still not advised to use them like previously, but you can actually use them. For types that have very good alternatives, just move away from them. And JDApps will even, if possible, they will even tell you what the alternative is. Of course, then a more interesting question is, once we can successfully run on Java 9, how can we actually move towards the module system? How can we modularize our code to make better use of the new possibilities in Java? So let's look at an example of that. Let's say that we have a demonstrator application, and this demonstrator is currently running on the class path. But this demonstrator is also using a library, in this case just a single library, commons lang. Let's take a look at the source code. It's just a main class, and we're using the important string utils.leftPath function. That's a great reason to drag in another module, obviously. And we're using this just like you would do on Java 8 using the class path. So when compiling with Java C, we have the class. We set up the class path to also contain commons lang, and we do the same thing for the Java command to actually run it. Now what we want to do is we want to start migrating our code, so this code that we just looked at, and move that towards a module, which means that we have to write a module info and actually move that away from the class path and towards the module path. But as soon as we start doing that, we run into a problem, because there's a rule in Java 9 that any code within a module can't read any code still on the class path. So it is possible to combine the class path and the module path, but types on the module path can't see anything on the class path. That's very problematic, because what can we do now? The only way to move forward using this is to also move commons length towards the module path. But that isn't great because, well, I'm not the author of commons length, so I don't really feel like going into either the source code and actually add the module info, or maybe just hack the jar file and add it straight in there. Especially if you are using a lot of modules or a lot of dependencies, well, that would just be way too much work. Luckily, there's a solution for this in Java 9, which are automatic modules. And an automatic module is a plain jar file without a module info that we just move to the module path. So we can just take an existing jar file, leave it the way it is, but just move it from the class path to the module path. And when we do that, it becomes an automatic module. And an automatic module has a module name, just like a real module. And this module name is derived from the file name of the jar. Basically, they just take the file name, strip off all version information, and that's your module name. Then it also exports everything. So every package contained in the jar file will be exported by this module. That makes it a pretty bad module because, well, that's not encapsulation at all, but at least it's a usable module. Besides exporting everything, it also reads all other modules. So you could say it requires all other modules. That's the effect that you get. Again, not exactly what you want, because you shouldn't read all other modules, but this is just an automatic migration scenario. So once we move this commons length jar file that we already had on the class path, once we move that towards the module path, we can start using it in our own module descriptor, in our own module info, like it would be a real module. So in this case, we can require commons length. And the only thing left for us to do is actually change our compile and run commands. You can see that there's no class path anymore, not for Java-C and also not for Java. But instead, we set up the module path, and the module path contains, of course, our own source code, but also the jar file containing commons length 3. And that's basically it. This way, we could just migrate towards using a module. So our code is now in a module without worrying too much about our dependencies. And it will be extremely useful for existing code where you might have, lots of dependencies, and those dependencies might have their transitive dependencies as well. Automatic modules are the way to actually migrate step by step towards that situation. Of course, we hope and expect that in the longer term, most libraries will actually contain a module info, but of course that just takes a while. So until that's the case, automatic modules are just a great way to slowly migrate towards Java 9 modules. As I said, Java 9 is not finished yet, and that means there's still a lot of discussion going on. And I strongly advise you actually take a look at the mailing list. There's a lot of traffic going on there, a lot of comments that people are giving on the current prototypes, and a lot of answers coming back from there. You will also find links there to the actual downloads of the Jigsaw builds. And there has been several iterations of that already. So based on the feedback that people have been giving, a lot of changes have been made, and actually a fresh prototype was just released 1.5 weeks ago. Check it out, check it with your use cases, and if possible also just try to give feedback. You can see there's still a list of open issues as well. And the good thing about that list of issues is that it's rapidly shrinking. A lot of the open issues that we had are already closed and are now available in the latest prototypes. There's still some interesting discussions going on there, so definitely take a look at that. But it's getting better and better. Just looking back at this talk, what is Java 9's promise, and how does it live up to that? Well, I think the important thing is that it brings modules to everyone. Unlike technologies like OSGI, which I personally actually like, but unlike that kind of technology, it's not just something extra. And that means that tool vendors and library authors, etc., they are pretty much forced to play nice with the module system in the future. And you already see that all the tool vendors are working on support for Java 9. And in the end, it will make modularity, well, a better story for day-to-day development. And well, just as a concept to have, that's something really important. So I think Java 9 is actually going to be a very nice release for all of us. Then again, as I said, Sandra and I are writing a book for O'Reilly that's currently available in early access release. That means that you can already buy it and read the first few chapters that we have released. And every time we release a new chapter, that will be added to the online version. Besides that, we also have a Twitter account where we post news both about Java 9 in general and about the book. And all the source code is available on GitHub. And with that, we're at the end of this talk. So thank you very much.
Awesome. Thank you very much to both of you guys who are giving this very technical session. So that's awesome. We've got a bunch of questions, and we have about 5 or 6 minutes. So let's try and do some super quick Q&A. Right. So from Bruno Ace in IRC, it seems to me like modules feature is more into making code more verbose than it already is, which is quite verbose. How can the module system actually help in the actual programming job without being more of a hassle than a helper?
Well, of course, designing towards modules is actually extra work. It will always be more work to actually properly design your modules and work towards that than just throwing everything together in a big monolith. But I think I don't have to explain that throwing everything together in a big monolith is actually not a great idea, and that in the longer term, when we start talking about maintainability, the fact that your code is nicely split up and nicely encapsulated will actually help you a lot. So yes, it's a little bit more work, but it's definitely paying off in the long term.
Okay. A couple of questions from the Java bin, the guys in Oslo. Can module info be multiple for a module, as in exposing some API and the other exposing another API?
You want to take it?
I didn't quite get the question, sorry.
So can module info be multiple for a module, as in one module info exposing one API and then the other exposing a different API?
I think we both still didn't quite get it. In the module info, you declare what export you have, and an export is a package that you want to export.
There can be multiple packages.
Yeah.
So I think the question may be about having multiple module info in the same module, maybe? I don't know.
Okay, that's not possible. You can only have one module info descriptor per module, but it can export different packages, and it can also require other modules. There's no two phases of a module. There's only one public phase.
Second question is from Java bin. Also, they'd like to know if module info could be annotated or externalized in XML or other properties or JSON files.
So annotations are definitely in, at least in the current state of the module system. The idea is that this will allow for extensions that have not been thought about before. XML, well, let's not go there. At least currently, there's no plan for that. What could happen, of course, is that Maven or Gradle or some other tool decides to generate part or whole of your module info. That's fairly feasible, I think. But in the end, the module info as it is will be the canonical source of information for the compiler, for the JVM, etc. And maybe you can generate that from some other parts of your build infrastructure. But in the end, you will need a module info descriptor. Okay. But it can be annotated. Yeah.
Okay. Harmeet Singh is asking how many modules that the JDK is actually going to be split into for Java 9.
There's about 90 modules currently in the full JDK.
90?
Yeah.
90. Okay. K77 is asking if there's any way to access hidden classes from non-explicitly allowed code, thinking about frameworks like Spring, which uses reflection a lot.
So there are a few answers there. I did show the escape hatches that you have. So basically in the Java commands, you can say, well, I do really want to break encapsulation and just work around the whole thing. So that's one thing you can but should not be doing. When it comes to frameworks, then it's a little bit different. Then in most cases, you want to hide your implementation classes, but you want to make it available for reflection. That's a really weird story, because that's kind of halfway encapsulation. You say, I don't really want to show it, but in the end, I do want to show it, right? Okay. So in the last prototype, not the current one, but the previous one, there was the idea of dynamic exports. And the dynamic export would export a package not compile time, but only at runtime. So that way, a framework could do its reflection magic, while other code could not access it compile time. There's a whole discussion going on about that, and they actually took it away from the current prototype. But it goes to a bit more detail, and into too much detail to actually discuss that now. But look at the discussion in the mailing list.
Okay. We might have time, depends how long the first answer takes, but we might have time for 2 more questions. What would happen if we're using packages or modules written in other languages like C or C++? That's from the Barcelona job.
Well, these wouldn't really be Java modules, so I'm not really seeing the connection here. If you have other languages like C or C++, that's just native code that you load into the JVM, just like you do now. So there's no link to the module system there.
Okay. And the other question is from Maxwell. Let's say my application depends on tens of external modules. Do I explicitly specify them on a module path, or can I tell Java or Javac to take all modules from a given folder?
So the module path, if you saw my demo, can actually be a folder just containing modules. And the JVM, when starting, takes the root module that you want to start. In my case, that was EasyText CLI. And it will recursively traverse all the require statements of this module to find all the modules it needs. And it tries to find them on the module path. And you don't have to explicitly list them all. You can just give a folder or multiple folders containing the modules, and it will resolve the modules. And if one is missing, it will fill at startup, like I showed in the demo. And if they're all there, they just get resolved. And the ones that are not necessary won't get resolved into the module graph and won't be loaded. So that's fairly nice.
Okay, so those are all the questions we have. That's a great session for questions, actually. I think.
Okay, cool.
Modules and Java 9 are certainly bringing up issues and questions a lot. So it's a great discussion. And let's see now how we're doing. This was session. I was all excited.